Hi everyone, welcome back in Road Zone Reviews. Elon Musk has done it again. He's stunned the automotive world with a move no one saw coming. This time, it's not about speed, range, or a new AI interface. It's something far more structural, and it could rewrite the future of vehicle safety, cost, and production forever. The new 2026 Tesla Model 2 features a shocking 0.9-meter gap in its chassis design, a move that has the industry split. Some experts are applauding it as a stroke of genius, while others are calling it a potential disaster waiting to happen. But here's what we know. Elon Musk didn't get to where he is by playing it safe, and he didn't set out to simply build electric vehicles. His goal has always been to reinvent how vehicles are built entirely. Tesla isn't just leading a car revolution, it's building a manufacturing revolution. But revolutions don't come without doubts, risks, or controversy. This 0.9-meter structural gap is now the center of one of the biggest safety debates Tesla has ever faced. So today, we're diving deep into the cutting-edge specs, stress tests, engineering logic, and safety simulations behind this bold design. You're going to see why this futuristic chassis might just be stronger, safer, and more efficient than anything we've ever seen in a budget EV. If you're already part of our 137,999 subscriber family that never misses a real-world breakthrough, hit that subscribe button and let the bell silently keep you informed. Let's get started. Part 1. Why Tesla abandoned welding for MegaCasting. To understand why Tesla made such a controversial move, we first need to understand how cars are traditionally built and what's fundamentally flawed about that approach. Right now, virtually every car you see on the road was assembled using a method that hasn't changed much in decades. The average vehicle underbody consists of about 400 individual stamped steel parts, all joined together using more than 1,600 weld points. That means 1,600 tiny connections, each one a potential weakness, each one a cost, and each one requiring precise quality control. These thousands of welds represent massive inefficiency in both safety and cost. Let's break that down. Every weld in a vehicle has about a 0.5% to 1% failure risk under extreme conditions. Multiply that by 1,600, and you're looking at dozens of structural vulnerabilities hidden within the very frame that's supposed to keep you safe. It's not just a safety concern, it's an economic one too. Every weld adds time, complexity, and money. In fact, traditional welding and stamping contribute an estimated $500 to $1,000 to the cost of each vehicle. Tesla saw the problem and engineered a radical solution: MegaCasting. Using 6,000 to 9,000 ton Giga presses, Tesla now creates large, structural components like the entire front or rear frame as a single aluminum piece. No more welding together hundreds of parts. No more 1,600 potential failure points. Just massive, ultra-precise structural castings forged with aerospace-grade aluminum alloys. This alone cuts production time by 30% and manufacturing costs by up to 40%. That translates to a staggering $5,000 to $7,000 in savings per vehicle. And that's what makes the new Model 2 on all-electric Tesla available for under $25,000. But now, about that 0.9-meter gap. This isn't some defect or compromise, it's a structural innovation. This gap is the interface between the front and rear MegaCastings, connected by the structural battery pack. While traditional thinking says more welds equal more strength, Tesla's data says otherwise. By reducing the number of joints and optimizing the quality of each connection, Tesla actually enhances safety, stiffness, and durability. A traditional underbody weighs around 270 kilograms. Tesla's MegaCast underbody, just 198 kilograms, 27% reduction in weight. That doesn't just mean better efficiency and acceleration, it also means fewer parts that can fail over time. And fewer parts mean fewer things that can break, shift, or degrade after years on the road. Part 2 is the 0.9-meter gap really stronger than welding. Let's dive into the part that has the entire automotive world buzzing. How can a vehicle with just 3 main joints be stronger than one held together by 1,600 welds? It starts with the materials. Tesla's custom aluminum alloy isn't your average metal. It has a yield strength of 140 to 175 megapascals compared to just 90 to 120 megapascals found in conventional automotive aluminum. That's up to 40% more structural strength, right from the base material. But the magic isn't just in the metal, it's in the bonding technology. Instead of traditional welds, Tesla uses aerospace-grade structural adhesives that can handle 30 MPa of shear force, equivalent to what holds commercial aircraft together at 35,000 feet. These adhesives are paired with ultra-high tensile bolts rated at over 1,200 MPa, clamped with forces exceeding 30,000 pounds. Each major connection in the Model 2's chassis has a bonding surface area of 2.7 square meters. Compare that to a tiny 2 mm weld bead and you start to see the scale of the improvement. You're distributing crash forces and stress loads across 1,000x more surface area. That's not just an upgrade, it's a complete redesign of how structural integrity is achieved. In real-world performance, Tesla reports a 30% improvement in torsional rigidity compared to the Model 3. That means the vehicle twists less under stress, making it more stable in collisions, better around corners, and safer during emergency maneuvers. And because the entire chassis weighs 20% less, the Model 2 is more agile, more efficient, and safer in high-speed impacts. Think about the speed of production too. Traditional stamping and welding take 5 to 6 hours just for the underbody. Tesla's MegaCasting, it's completed in under 10 minutes per section. That's a 36x improvement in production speed, while delivering better safety and structure. Part 3. Can a stitched frame be safer than a single steel body? So here's the big myth. People think that a stitched-together car sounds flimsy, weak, incomplete. But that assumption couldn't be further from the truth. Tesla's structure was inspired by biomimicry, specifically the human spine. Think about it. Your spine isn't one solid piece. It's made of rigid vertebrae connected by flexible joints. It's this distributed, joint-based structure that gives it both flexibility and strength. Tesla's MegaCast front and rear frames are like vertebrae. The battery pack and adhesive bolts joint the 0.9-meter connection serves as the flexible, force-absorbing disc that holds everything together. The results are stunning. Tesla's Model 2 chassis achieved 35,000 Newton-meters per degree of torsional rigidity compared to the 26,000 Newton-meters per degree of the Model 3. In simulated crash tests at 64 and 72 kilometers per hour, the Model 2 absorbed 25% more crash energy, while cabin intrusion was reduced by 15%. And it's not just theory. Tesla validated this with over 40,000 virtual crash simulations and extreme physical testing, including brutal off-road trials with the Cybertruck. That same bonding system held up under 50 kilometers per hour off-road impacts with zero structural damage to the joints. If it can handle that, it can absolutely protect your family on the highway. Part 4. Maintenance, repair, and real-world benefits. Let's talk practicality. What happens if your Tesla gets into a fender bender? Will repairs be more expensive? Actually, no. MegaCasting means fewer parts, fewer potential points of failure, and easier modular repairs. Instead of reconstructing entire sections, Tesla service centers can replace individual castings or use specialized aluminum welding to patch minor damage. The result? Repairs typically cost $200 to $500 compared to over $1,000 for traditional frame fixes. Over time, owners can expect to save $500 to $1,000 per year on maintenance alone. That adds up to $5,000 to $7,000 over a decade, making the Model 2 not just more affordable upfront, but also more economical to own long-term. This is what legacy automakers don't want you to realize. Tesla's so-called stitched-together approach isn't a weakness, it's a superior construction philosophy. It's safer, smarter, stronger, and cheaper to repair. It's everything car buyers have been asking for, but legacy systems were too slow, too outdated, or too afraid to deliver. So now, the mystery of that 0.9-meter gap is fully revealed. It's not a compromise, it's an engineering triumph. It symbolizes the beginning of a new chapter in vehicle manufacturing, a chapter where safety is optimized, cost is reduced, and sustainability is prioritized not as trade-offs, but as integrated outcomes of smarter design. The 2026 Tesla Model 2 is the most advanced budget EV we've ever seen, not just because of its technology, but because of how it's built from the ground up. That gap you've heard people whisper about, that's the very space where automotive history is being rewritten. If this breakdown helped you see Tesla's innovation in a whole new light, let me know below. Type yes in the comments if you now trust this radical design, and if you want to be part of the next big chapter in electric vehicles, hit subscribe and let that bell keep you updated quietly but powerfully. This is Road Zone Reviews. And remember, the future isn't coming, it's already here. Stay tuned.